Alright, Department of Energy Fundamental Handbooks, Mechanical Science, Module 4, Valves, references, Babcock, Wilcox steam, its general use, fluid flows, pump blank channels, heat transfer, thermodynamics, fluid flow fundamentals, and Handbook of Valves with pneumatic hydraulics. Alright, your valve function, that's too far away. Alright, your valve functions in parts. Valves are most common single piece of equipment of the Department of Energy facility. Although there are many types of shapes and sizes of valves, they all have the same basic parts. This chapter will review the common parts of the function of a valve. E11. Describe the four basic types of flow control elements employed in valve design. Describe the valve stem leakage is controlled. How valve stem leakage is controlled. Given the drawn valve, identify the following: bonnet, stem, actuator, packing, seat, and disc. Introduction: a valve is a mechanical device that controls flow of fluid and pressure within a system or a process. A valve controls the system, process, fluid flow, pressure, performing any of the following functions: stopping and starting fluid flow, verifying throttle and the amount of fluid flow, controlling the direction of fluid flow, regulating downstream system pressure, relieving component and piping overpressure. There are many valve design types that these satisfy one or more functions identified above. The multitude of the valve types in the design safety accommodate the wide variety of industrial applications. Regardless of the type, all valves have the following basic parts: bonnet, trim, internal elements, actuator, and packaging. The basic parts of the valve is illustrated in Figure 1. The valve body is sometimes called itself the primary pressure boundary of a valve, or called the shell. It serves as a principal element valve assembly because it frameworks that holds everything together. The body is the first pressure boundary of the valve. Resists fluid pressure loads with connecting the pipe. It receives inlet and outlet pipe through threaded, bolted, welded joints. Valve bodies are cast and forged into the variety of shape, although the sphere or cylinder with either theoretically most economical shape to resist fluid pressure with the valve is open. There are many other considerations. For example, many of the valves require portion across the valve body, supporting seat opening, which is the throttle orifice. The valve with the closed and loading on the body is difficult to determine. The valve end connection also distorts the load with a single stem of shear. More complicated shapes, easy to manufacture, assembly, and costs are additional important consideration. Hence, the basic form of the valve body typically is not cylindrical, but ranges from simple block shapes to highly complex shapes, which bonnet removable pieces to make assembly possible forms part of the pressure-resisting body. And then we're going to look at the picture. This is your actuator at the top, and that shows the packaging, the bonnet, the stem, the body, the disc, the seat. And those are your basic parts of the valve. Narrowing fluid passage venturi effect is also a common method of reducing overall size and cost of the valve. In other instances, the large ends are added to the valve for the connection of the larger line. Your valve bonnet. To cover the opening of the valve body is the bonnet. It is sometimes designed in the body itself is split into two sections that bolt together. Like valve bodies, bonnets are vary in design. Some of the bonnets function simply as a valve cover, while the others support valve internals accessories such as stem, disc, and actuator. The bonnet is the second and principal pressure boundary of the valve. It is cast and forged in the same material the body is connected with the body with a threaded, bolted, welded joint. In all cases, the attachment of the bonnet of the body is considered pressure boundary. This means that the welded joint and bolts of that connection of the bonnet over to the body are pressure-retaining parts. Valve bonnets, also necessary to the most valves, represent the cause of concern. Bonnets can complicate the manufacture of the valves, increase valve size, represent the significant cost portion of the valve cost, and are a source of potential leak. Your valve trim. And the internal elements of the valve are collectively referred to as the valve trim. The trim is included with the disc, seat, stem, sleeves needed for the guide to the stem. The valve performance for the trim of the disc seat interface relationship with the disposition of the seat. Because of the trim of the basic motion flow control are possible, the rotational motion of the trim design with the disc slides closely past the seat to produce a changing in the flow of the opening. Linear motion of the trim design, disc lifts perpendicularly away from the seat with the annular orifice appears. Your disc and seat. The valve having a bonnet with a disc of a third-party principal pressure boundary. The disc provided with the capability of permitting and prohibiting fluid flow. When with the disc closed, the fuel system is applied across the disc outlet side is depressurized. For this reason, the disc is pressure retaining part. Discs are typically forged in some designs, hard surface to provide good wear characteristics. A fine surface finish over the seating area with the disc and the necessarily good sealing when the valve is closed. Most of the valves are named in part according to the design of the disc. The seat or seal rings provide with a seating surface for the disc, and some design of the body is made to serve the seating of the surface. The seal rings are not used. In other design, forged seal rings are threaded and welded to the body that provide the seating surface. To improve the wearing resistance of seal rings, the surface is often hard-faced by welding, and the machine contact surface of the seal ring. A finished surface finish of the seating ring is necessary for the good sealing of the valve closed. Seal rings are not usually considered pressure boundary parts because the body has sufficient wall thickness to withstand design pressure without relying upon the thickness of seal rings. Your stem. The stem, which connects the actuator disc responsible for the positioning of the disc of the stem, is typically forged connected to the disc, threaded by welded or welded joints. For the valve design requiring stem packaging, sealing, preventing leakage, fine surface finish of the stem of the area seal is necessary. Typically, the stem is not considered the pressure boundary part. Connection of the disc to the stem can allow some rocking rotation to ease position of the disc on the seat. Alternatively, the stem may be flexible enough to let the disc position itself against the seat. However, the constant fluttering of rotation and flexibility loosely connected to the disc can destroy the disc and connection of the stem. Two types of the valve stem are rising stems and non-rising stems. Illustrated in Figure 2 and 3, these two types of stems are easily distinguished by observation. The rising stem valve stem will rise above the actuator as the valve is open. This occurs because the stem is threaded and mated with the bush threadings over the yoke, thus integral part of the often mounted is to the bonnet. Alright, this shows your closed and open position with the stem, hand wheel, yoke, packaging, gland, bonnet, gate, and body. And that's open and closed as it moves up the yoke and the stem. That's Figure 2 is your rising stem. Figure 3 is your non-rising stem. Shows the closed portion of the body, the stem, the yoke, the hand wheel, the packaging gland, the bonnet, the gate. As you notice, the thread is opposite direction. There's no upward stem movement over the outside valve of the non-rising stem. So there's no upward moving stem outside of the valve of the non-rising stem. For non-rising stem, the valve disc is threaded internally and mates with the stem threads. The valve actuator operates stem and disc assembly. Operator may manually be operated with a hand wheel, manual lever motor operator, solenoid operator, pneumatic operator, hydraulic ram. In some designs, the actuator is supported by a bonnet, and the other designs are yoke mounted with a bonnet supports the actuator. Except for the certain hydraulic control valve, the actuators are outside of the pressure area boundary of the yoke when used, always outside of the pressure area boundary. Alright, your valve packing. Most valves use the same form of the packing, preventing leakage of space between the stem and the bonnet. The packaging is commonly called a fibrous material such as flax or any other compound as Teflon that forms a seal between internal parts of the valve and the outside where the stem extends through the body. Valve packaging must be properly compressed to prevent the fluids loss and damage to the valve stem. Valve packaging is too loose, the valve will leak, which is a safety hazard. If the packaging is too tight, it will impair the movement and possibility of the damage to the stem. Alright, introduction to type of the valve. Because of the diversity of the type of the stem, the fluid environments in which the valves must operate, the vast array of the valve types have been developed. Examples of the common types are the globe valve, the gate valve, the ball valve, the plug valve, the butterfly valve, the diaphragm valve, the check valve, the pinch valve, the safety valve. Each type of the valve has been designed to specify the needs. Some of the valves are capable of throttle flow, other valves can only stop flow, other works well in corrosive systems, other handle high pressure fluids. Each of the value type has certain inherent advantages and disadvantages. Understanding the difference, how they affect valves, application, operation necessary to successfully operate the facility. Although all valves have the same basic components functioning for the control of flow, in some of the other fashions, method of controlling the flow can vary dramatically. In general, there are four methods of controlling flow and through a valve. Move a disc and plug it against an orifice, for example, a glove or a needle type valve. Slide a flat cylindrical or cylindrical surface across an orifice, for example, a gate and plug valves. Or rotate a disc or ellipse which the shaft extends across the diameter of the orifice, for example, a butterfly or ball valve. Move a flexible material into the flow house passage, for example, a diaphragm or pinch valves. Each method of control flow of the characteristics makes the best choice for given application of the function. Alright, your summary. The following important information in the chapters below. The valve function basics part summary. The 4 basic types of the flow of the control elements employed with the valve design. Move a disc and plug it and against the orifice. For example, the globe needle type, the slide flat cylindrical surface across an orifice. For example, gate or plug valve. Rotate a disc ellipse with the shaft extending through the diameter of the orifice, for example, the butterfly or ball valve, and the flex material flow passage of the diaphragm pinch valve. The valve stem leakage is usually controlled by properly compressing the packaging around the valve stem. There are 7 basic parts that are common to most valves. Alright, your type of the valve. Due to the various environments, the system fluids, system conditions, which the flow must control, a large number of the valve design have been developed. Basic understanding the difference between the various types of the valve, the difference of each of the valve function will ensure the proper application of each valve during the design, proper use of each valve type during operation. Given a drawing valve, identify each of the following type of the valves: globe, gate, plug, ball, needle, butterfly, diaphragm, pinch, check, safety relief, and reducing valve. Describe the application of the following type of the valves: globe, gate, plug, needle, ball, butterfly, diaphragm, pinch, check, safety relief valve, reducing valve. Or the gate valve is a linear motion valve that we use to start or stop flow of fluid. However, it does not regulate the throttle flow. The name of the gate is derived in appearance of the disc and flow of the stream. Figure 4 illustrates the gate valve. The disc of the gate valve is completely removed from the flow of the stream. The valve is fully open. The characteristic often offers virtually no resistance to flow of the valve is open, hence there is little pressure drop across the open gate valve. When the valve is closed, the disc seal ring contact surface exists at 360 degrees. Good sealing is provided. With proper mating of the disc of the seal ring, very little or no leakage occurs across the disc if the gate valve is closed. Alright, shows the back out of this, the gate valve. Shows your hand wheel, your stuffing box, your packaging material, the bonnet, the gasket, the stem, the flange, the gasket and the flange, and then the disc and the body. Alright. An opening gate valve with a flow path enlarged with a highly nonlinear manner with respect to the percent of the opening. This means the flow rate does not change evenly with the stem travel. Also, proportionally open gate disc tends to vibrate from the fluid flow. Most of the flow changes occurs nearly shut off with a relatively high fluid velocity, causing the disc or seat wear. Eventually, a leakage is fused to regulate flow. For this reason, the gate valves are not used to regulate flow or throttle flow. A gate valve can be used in a wide variety of fluids provided with a tight seal when closed. The major disadvantages of the gate valve are not suitable for throttle applications. It is prone to vibration in partially open state. It is more subject to seat and disc wear than global valve. Repair such slapping grinding generally more difficult to accomplish. Or gate valve disc design. Gate valves are available in a variety of disc classification. Gate valves usually made by the type of the solids wedge, flexible wedge, split wedge, or parallel disc. Solid wedge, flexible wedge, split wedge are usually in valves, including inclined seats. Parallel with the disc, using the valve with the handling parallel seats. Regardless of the style of the wedge disc, even the disc usually is replaceable and surface with the solids, and the high velocity may cause rapid erosion. Seat disc of the components, which should be the highly surface hardness, should be the replacement seats as well as the disc. If the seats are not replaceable, the damage required for the removal of the valve with line with the refacing of the seating of the refacing of the seat in place. Valves as being in the corrosion surface should normally be specified with a replaceable seat. Solid wedge. The solid weight gate valve shown in Figure 5 is most commonly disc used. The simply strength of the valve, typically the wedge is installed with any of the positions suitable for almost all fluids, and is practical for turbulent flow. The flex wedge gate, the Figure 6 is a one-piece disc of the cutting around the parameter, improve the ability of the match air of the occasion with the angle between the seat. Cut varies in size, shape, and depth. A shallow, narrow arrow cut, light flexibility, retaining strength. Deeper, wider cut, cast and recess leaves little material at the center, which allow flexibility, both compromise strength. A correct profile of the disc and half of the flex wedge disc can be general. Give the uniform of the deflection prop of the disc edge so the wedging force applied in the seating will force the disc seating surface uniformly tightly against the seat. Alright, figure 5 shows your solid wedge gate valve. Figure 6 shows your flexible wedge gate valve. The gate valves are used in stem systems that have flexible wedges for the reason for the use of the flexible gate with the vent binding of the gate within the valve when the valve is closed position. When steam lines are heated, they expand, cause the distortion over the valve body with the solid gate that fits snugly between the seat of the valve and the cold stem system. When the system is heated and the pipes elongate, the seats will compress against the gate and clamp the valve shut. The problem is overcoming using a flexible gate, which design allows the gate to flex and the valve seat compresses it. Major problem associated with flexible gate: the water tends to collect in the body neck under the certain condition of the emission of the steam may cause the valve body to neck to rupture, bonnet to lift off, and the seat the ring and to collapse. The following correct warming procedures prevent this problem. Or your split wedge. Your split wedge gate valve shown in figure 7. The arm of the ball and socket is designed with self-adjusting, self-aligning. Both seat surfacing of the disc is free, but it adjusts itself and surfacing one half of the disc slightly out of alignment from the form matter lodged between the disc half and the seat ring. But the type of the wedge is suitable for the handling non-condensing gases liquid with a normal temperature for the practical corrosive liquid, so the freedom movement over the disc is carried prevents the binding event. Even the valve may be closed with no hot or later control contract due to the cooling. The type of the valve should be installed with the stem in the vertical position. Alright, figure 7 shows your split wedge gate valve. Parallel disc. The parallel disc gate valve figure 8 is designed to prevent the valve of the binding due to thermal transition. This is designed to the both low and high pressure application. Wedge surfaces between the parallel phase disc halves are caused to press together under the stem thrust and stress spread apart the disc to seal against the seats. They tamper the wedge may be part of the disc half. They may be separated elements of the lower wedge from the may be bottom of the on a rib of the valve bottom of the stem. Can be developed seating in the force one version of the wedge contact surface contain curve to meet the point of contact with the close to optimum. Other parallel disc gate of the two halves do not move around under the wedge action. Instead of the upstream of the pressure holds down the downstream disc against the seat. Under a carrier ring and lift the disc and spring with the spring holds the disc apart in the seat when there is no upstream pressure. Or another parallel gate disc design provides the sealing of one port of the design. The high pressure side pushes back the disc open the relief of the disc on the pressure side, with the force disc closed on the low pressure side. With the such designs amount of the seat located 10 degrees. The differential pressure across the seat increases. These valves usually have a flow direction which will show the size of the higher pressure relieving side. Care should be taken to ensure that these valves are not installed backwards in the system. Alright, and this shows your parallel disc gate. Shows the actuator yoke rods, anti-rotating device, carrying ring, spring, and disc half. Some parallel discs used at high pressure system are made with an integral bonnet valve with a bypass valve, a three-way valve with a position line with a bypass in order to equalize the pressure across the disc prior to opening the gate valve that's closed with a three-way with the position to the vent with the bonnet on one side of the other, and to prevent moisture with accumulating with the bonnet. The three-way valve is positioned with a high-pressure side with the gate valve closed to ensure the flow, but it does not bypass the isolation valve. The high pressure acts against the spring compression forces, and one gate off its seat. Three-way valve vents from the flow back from the pressure source. Alright, your gate valve stem design. The gate valve is classified either by rising or non-rising stem valves. For a non-rising stem gate valve, the stem is threaded on a lower end of the gate, and using a hand wheel on the stem to rotate with the gate, it travels up and down from the stem of the reds, while the stem remains vertically stationary. This type of the valve will also always have a pointer type indicator threaded onto the upper end of the stem to indicate the valve position. Figure 2 and 3 illustrates the rising stem gate with a valve with non-rising stem gates. Non-rising stem configuration play with the stem threads of the boundary established by the valve packing out with the contact of the environment. Configuration assures the stem merely rotates the packaging, which without much damage carrying dirt into the packaging from the outside to the inside. Rising stem gate valves are designed so the stem is raised out of the flow path with the valve is opening the rising stem gate valve, then coming in two basics design. Some of them stem have the hand wheel while the others have the stem threaded to the bonnet. Your gate valve seat design. Search for the gate valve with either provide with integral valve body seat ring type of the configure instruction. Seat ring component instruction provides the seat seat, which are either threaded into position or pressed into the position, seal welded body of the valve. The body later form of construction is recommended with a higher temperature serve with an integral seat with the sheet with some of the material construction valve body wall of the press and threaded in seat permit variation rings with a hard facing may be supplied with the application where they are required. Alright, your small forward steel gate valve may be hard force seated pressed into the body, and some of these series with the type of the valve with the size of between 1/2 to 2 inches, rated at 2,500 psi gallon steam service or pressure psi gauge. 2,500 psi gauge, and the large gate valve with the disc are often with a solid wedge type with the seating rings threaded into the welded in and pressed in. Screwed and seated rings are considerably replaceable since they may be removed or new seats installed. Alright, your global valve. The global valve with the linear motion valve that you stop and start regulate fluid flow. The Z body of globe valve is illustrated in Figure 9. As shown in Figure 9, the globe valve disc can totally be removed from the flow of the path, completely closed. Essentially, principal globe of the valve operation, perpendicular movement of the disc away from the sheet with the cup of the annular space between the disc and seat ring. Gradual close of the valve is closed with the characteristic give of the globe with a good throttle ability, which permits the using of the regulating flow. Therefore, the globe valve must be used at both stop and start fluid flow for regulating flow. Shift the head and wheel, the stem, the bonnet, and the disc in the seat. When compared to gate valve with the globe valve, it generally yields too much less than leakage of the vest because of the disc to seat. Ring contact is more than right angles. Permits the force closing into a tight seal at the disc. Globe valves can be arranged so the disc closes again for the same direction of fluid flow, the disc again for the direction of flow with the kinetic energy fluid impedes closing and aids opening the valve with the disc closed with the same direction of flow with the kinetic energy with the fluid aids closing impeds opening with the characteristic preferable to the other design. Quick acting stop valves are necessary. Globe valves also have drawbacks. Most evident shortcoming symbol of globe valve with a high head loss from 2 to more right angles turns from the fluid flow. The obstruction of the discontinued flow path leads to head loss. Large high pressure lines of fluid dynamic effects with the pulsation impact with the pressure drop can damage trim, stem packaging, and actuators. Addition, large valve sizes require considerable power to operate with this, especially with noisily, highly pressure applications. Other drawbacks: globe valves are larger openings necessary for the disc assembly, heavier than weight with the other valve with a slow flow rating of the same anti-levered mounting of the disc to the stem. Your globe valve body design. There are 3 primary body designs of globe valve: Z body, Y body, and angle body. Your Z body design, simplest design, most common in the water application. The Z body with its illustrated Figure 9 body design, Z-shaped diaphragm portion across the globe of your body contained with the sheet with a horizontal with the sheet that allows the stem disc to travel the right angles to the pipe access. The stem passes through the bonnet and attached with the large opening of the top of the valve body. This provides a symmetrical form of the simplified manufacture, installation, and repair. So we have Figure 10 is Figure 9 was your Z body, and then Figure 9 is your Y body. The Y body design. Figure 10 illustrates a typical Y body globe valve design remedy with a high pressure drop inherent globe valve with the stem seats. The seat and the stem are angled at approximately 45 degrees. The angle yields a straighter flow path. The full opening provides the stem, bonnet, and packaging relative to the pressure resistant envelope. The Y body globes are best suited for the high pressure. Other surfaces in small size is for intermittent flows of the pressure loss from the must be as important, but the SL of the consideration favoring the Y body design. Hence, the flow patch design on a small Y body globe valve is not carefully streamlined as of the larger valve bodies. So this is your Y body globe valve. Alright, your angle globe valve shows the hand wheel, steam, stem, bonnet, disc, and seat. Your angle valve body design. Let me see if alright. Your angle body globe valve design. Illustrating Figure 11, the simple modification of basic globe valve. However, having the ends right angle with the diaphragm can be simple, flattened plate with the fluid able to flow through the only single design 10-degree turn discharge downward more symmetrically through the discharge of the ordinary globe. The particular advantage of the angle body is that it can function as both a valve and a piping elbow. For moderate conditions, pressure, temperature, flow of the angle valve closely resemble the ordinary globe. The angle valve discharge conditions are favorable with respect to the fluid dynamics and erosion. That's your angle valve design. Alright, your globe valve disc. The globe valves use 1 of 3 basic discs design: the ball disc, composition disc, or the plug disc. The ball disc hits in the tapered flat surface of the sheet, but the ball disc is designed to use primarily relatively low pressure, low temperature system capable of flow throttling flow, and primarily uses start and stop flow. Composition disc, designed with a hard non-metallic insert ring on the disc. The insert with the ring creates a tighter closure. Composition disc, primary uses steam and hot water applications. Resistant erosion are sufficiently resilient to close on solid particles without damaging the valve. Composition disc are replaceable. Or your plug disc. Because of the configuration, plug disc provides a better throttle than a ball composition design. Plug discs are available in a variety of simple configurations. In general, they are long and tapered. Alright, your globe valve disc and stem connection. Globe valves employ the two methods of the connection disc and stem T-slot construction. Disc nut construction. The T-slot design disc slips over the stem of the disc nut design with the disc is screwed into the stem. Your globe valve seat. With the globe valve seats have an integral screw into the valve body. Many globe valves they have the back seats. A back seat is a seating arrangement that provides a seal between stem and bonnet where the valve is open with the disc seats against the back seat. The back seat design prevents the system pressure from building against the valve packaging. Our globe valve direction flow. For the low temperature application globe, an angle valve with the ordinarily installed with the pressure for the under of the disc that promotes the operation, help the protect of the packaging, eliminate a certain amount of the corrosion correction action of the seat of the disc surfaces. For high temperature stem surfaces of the globe valves installed where the pressure is above the disc, otherwise the stem will contract and open upon cooling and tend to lift the disc off the seat. Your ball valve. The ball valve with a rotational motion valve with what is shaped that is used to be ball-shaped disc to start with the start fluid flow. Start and stop fluid flow. The ball is shown in figure 12 with performs the same function of the disc of the globe valve. When the valve is handled, turn to open valve of the ball, rotate with the point where through the hole where the ball is in line with the valve body, inlet and outlet. When the valve is shut off, the valve is rotated so that the hole is perpendicular with the flow open to the valve body, and the flow is stopped. Most ball valve actuators are quickly acting type that require the 90-degree turn valve with the operating of the handle operating the valve. The ball valve actuator planetary gear operated type of the generator and gearing allowed the use of relatively small hand wheel operating the force to operate fairly large valve. Some of the ball valves help the cylindrical surface coated with the plug with it just off to one side with the O1 open position, rotate the flow passage of the block flow completely. Seating to accomplish eccentric movement of the plug of the valve that requires no lubrication can be used with throttle servicing. Alright, this shows your typical ball valve. So you have your body, seat, ball, packaging, stem, and actuator, and then it shows the opening of the ball body and actuator, the throttled body, and the closed body. The advantages of the ball valve generally is less expensive than any of the valve configuration. It has low maintenance cost, quick order turn off operation. Ball valves are compact and require no lubrication, give the tight seal with low torque. Disadvantage: conventional ball valves have relatively poor throttling characteristics. In throttling position, partially exposed, the seat rapidly erodes because of the impingent high velocity flow. Port patterns. Ball valves are available in venturi, reduced, and full port pattern. Full port pattern has a ball with a bore equal to the inside diameter of the pipe. Valve materials. Balls are usually metallic bodies and with a trim seat with produced with elastometric or elastic materials resembling rubber material. Place construction is also available. Resilient seats of the ball valves are made with various elastomagnetic material. The most common seat with them may be Teflon, filled Teflon, nylon, Buna, and neuropropene in combination with these. Basically, the elastrometric of the valves cannot be used with elevated temperature. Care must be used with a selection seat with the material to ensure capability with the materials being handled in the valve. The ball valve stem design. The stem of the ball valve is not fastened to the ball, but normally rectangular portion of the ball end of which is fitted with a slot cut into the ball. The enlargement permits over the rotation of the ball. The stem is turned. Alright, your ball valve bonnet design. A bonnet cap with fastening of the body with a hole for the stem assembly with the ball and play with adjustment of the ball. Bonnet cabinet permits the compression of the packing supplied with a stem seal. Packaging for the ball valve stem is usually configuration of the die form packaging rings with normally Teflon filled with Teflon impregnated material. Some ball valve stems are sealed with a range of O-rings rather than packaging. Ball valve position. Some ball valves are equipped with the top that permit only 90-degree rotation, but the others do not have the top that may be rotated 360 degrees. With or without stop of 90 rotation is all that is required for the closing and opening of the ball valve. Handle indicates the ball valve position. The handle lies along the axis axis of the valve is open and the handle lies in a 90-degree craft. The valve is closed. Fill in ball valve stem to the groove cut top of the face of the valve stem. Show the flow of the path through the ball observation groove position. Indicate the position of the port or through the ball. Features particular advantage of the ball multi-port ball valves. Or your plug valve. The plug valve is the rotational motional valve used for the start and stop fluid flow, but derived with the shape of the disc and resembles the plug. The plug valve shown in Figure 13. The simplest form of the plug valve is a petcock. The body of the plug valve is machined to receive the tapered cylindrical plug. The disc is solid plug with a board passage right angle to the longitudinal axis of the plug. So you have your handle, your grease fitting, your stem, your packaging gland, your packaging, your plug retainer, your body, your plug closed, plug port, and grease cover grooves. And this shows your plug valve flow closed, throttled, and then open. In opening position, the plug line over the inlet outlet ports of the valve of the plug is turned 90 degrees. Open position, solid part of the plug. Those two flows to it. Plug valves are available either lubricated, non-lubricated design with a variety of the styles of ports opening with the plug as well as the number of the plug's design. Are your plug ports. Important characters of the plug valve is adaptation with the multi-plug core instruction. Multi-plug valve that will be widely used. The installation simplifies the piping to provide more of the convenient operation of the multi-gate valves. These eliminate pipe fittings that use the multi-port valve that, depending on the number of the ports and plug valve, eliminates the need for as many as 4 conventional shut-off valves. Plug valves are normally used with the non-throttling and throttling off operation, on and off operation, particularly where the frequent operation of the valve is necessary. The various valves are not recommended for throttling. Together, they like a gate valve. High percentage of the flow occurs near the shutoff at the high velocity. However, the diamond-shaped port has developed for the throttling services. Multi-port plug valves. Multi-port plug valves, particular advantage of the traveler's transfer line is diverting surfaces of the simple multi-port valve being installed in lieu of 3 or 4 gate valves as other type of the shutoff valve. The disadvantage of the multi-valve configuration not complete with the shutoff flow. In most cases, one flow path is open and the valves are intended to divert the flow, the one while shutting off the flow to the other lines. And if complete shut-off is a requirement, if necessary, style multi-port may be used and permit this. A secondary valve shall be installed with the main line head with the multi-port valve to completely shut off the flow. So multi-port configuration simultaneously flow to one port as possible. Great, with the care should be taken and specified with a particular port arrangement required to guarantee that the proper operation will be possible. Your plug valve disc, plug either around with a cylindrical taper. The most various type of the ports with the opening with either varying degree, either relative with the corresponding inside diameter of the pipe. Your rectangular port plug, the most common port shape of the rectangular port with the rectangular representing at least 70% of the corresponding pipe cross-section area. Your round port plug. The round port plug is a term to describe the valve with a round opening through the port. As the plug of the port is the same size large as the pipe and inside the diameter referred to as a full port. The opening of the small part, smaller than the pipe's inside diameter of the port is referred to as a standard round port. The valve, standard round ports are used only where restriction flows is unimportant. Alright, your diamond port plug. The diamond port plug is a diamond-shaped port, but through the plug with a design for the throttling shift. All the diamond port valves are venturi restricted flow type. Your lubricated plug valve design. Clearance and leakage of the prevention of the chief consideration plug valve. Any plug valve with all metal construction and these various narrow gaps around the plug can allow the leakage of the gap to reduce the sinking of the tapered plug with deeper than the body. Actuation torque with climb rapidly gouging and can occur with the remedy with the condition of the serious grooves around the plug body and plug port with the opening for the supply with the grease prior to actuation. Applying grease lubricated with the plug motion seal with the gap between the plug and the body. Grease is injected into the fitting of the top of the stem, travel down through the check valve of the passageway, blast the plug, top of the groove of the plug, down the well below the plug. The lubricant must be compatible with the temperature with the nature of the fluid. All manufactured lubricated plug with the valves that have developed the serious lubricating compatible with wide range media. Recommendations should be followed as to which lubricant is best suited for the service. Most common fluids controlled by the plug valve. The gases, the liquid hydrocarbon, some of the water lines have these valves that provide with lubricant contamination, not serious danger. Lubricated plug valve that may be as large as 24 inches have pressure capabilities up to 6,000 psi gauge. Steel and iron bodies are available, and plugs can be cylindrical or tapered. Non-lubricated plug. There are two types of non-lubricated plug valve: lifted type and then elastomer sleeve or plug coated. If type of the valve provides means mechanical lifting the tapered plug slightly to the disengage of the seating of the surface of the permit easy rotation. The mechanical lifting can be accomplished by the cam external lever. It is common in non-lubricated plug valve having a isometric sleeve with a Teflon completely surrounding the plug, retained locked in place with the metal body. Design resolved with the primary seal being maintained between the sleeve of the plug at all times, regardless of its position. Teflon sleeve is durable in air, all too fairly rarely encountered chemicals. Also, low coefficient of friction in there is therefore self-lubricated. Manually operated plug valve installation. The installation plug valves care should be taken to allow the room of the operation to handle the level of the wrench of the manual operator, usually longer than the valve that rotates to the valve position parallel with the pipe with the position 90 degree to the pipe. Plug valve glands. The gland of the plug valve is equivalent to the bonnet of the gate of the glove valve. The gland is secured with the stem and assembly of the valve body with the three general types of glands are single gland, screwed gland, bolted gland. Sure, the tight valve of the plug is seated at all times. Gland adjustment should be kept tight enough to prevent the plug from being unseated, exposing seating of the surface of the live fluid. The care should be exercised to over-tighten the gland, which result in metal-to-metal contact between the body and the plug. The stress of the metal-metal contact creates an additional force with requirement extreme effort over the operate the valve. The diaphragm valve. The diaphragm valve, linear motion valve, is used with the start regulate with the top of the fluid flow, with the name of the derived with a flexible disc, which remains the seal located in the open area of the top of the valve body form a seal. The diaphragm valve is illustrated in Figure 14. Figure 14 shows the straight diaphragm valve. Opening, throttling, and closing. Our diaphragm valves are in effect with a simple pinch clamp valve with a resistant flexible diaphragm connected with the compressor with the top molded with the diaphragm with the compressor is moved with the down, the valve stem with the diaphragm lift with the compressor is raised, add with the compressor is low with the diaphragm is pressed against the entire bottom and the straight through valve illustrated in Figure 14 with the body wear with the weir type valve illustrated in Figure 15. Our diaphragm valves can be used with the throttling strip with the weir type with the better throttling valve but has limited range. The throttle characteristics are essential through the quick opening valve because of the large shut-off area along the seat. Where type diaphragm valve is available to control small flows, usually a two-piece compressor component, but instead of the entire diaphragm lifting off the wear of the valve is opened with the fierce increments of the stem travel to raise the inner compressor of the component, but then cause the only central part of the diaphragm to lift. This creates relatively small opening from the center of the valve with the inner compressor that is completely open. The outer compressor of the component is raised along with the inner compressor. The remainder of the throttle is similar through the throttling and it takes place with the conventional valve. Diaphragm valves are particularly suited with the handling of the corrosive fluids, fibers, slurry, radioactive fluids, or other fluids that must remain free from contamination. Alright, diaphragm construction. The operating mechanism of the diaphragm valve is not exposed with the media within the pipeline stick, and viscous fluids cannot get into the bonnet and interfere with the operating mechanism. Many fluids that would clog, corrode, and gum up the working parts must otherwise type of the valves will not pass the diaphragm valve without causing problems. Conversely, lubricants used for operating mechanisms cannot be allowed to contaminate the fluid being handled. There are no packaging glands to maintain no possibility of stem leakage. The wide choice of the available diaphragm material. The diaphragm life depends upon the nature of the material handled, temperature, pressure, frequency of operation. Some of the elastometric diaphragm materials are unique and either excellent resistance to certain chemicals with a high temperature. However, the mechanical property of the elastometric material will be lowered high temperature possible destruction diaphragm at a high pressure. Consequently, the manufacturer will be consulted with whether they use the elevated temperature applications. Alright, this shows your wear diaphragm valve. Hand wheel, bonnet, sleeve, bonnet assembly, stud, reinforcement, compressor, bolt holes, stem, sealing band, port wear, and flow passage, end connections, and body. Shows your opening, throttle, and closing. All isometric materials operate below the 150 degrees. Some of them will function at high temperature. Viton, for example, is known for the excellent chemical resistance stability of the high temperature. However, the fabricated with the diaphragm of the Viton is subject to low tensile strength, and just enough the elastometric would be elevated temperature fabric and the bonding strength is also lowered to elevated temperature. In case the Viton temperature may be to reach for the bonding strength become critical. Fluid concentration, also consideration, diaphragm selection made with the diaphragm materials exhibit satisfactory corrosion resistant to certain corrodants upon specific concentration or temperature. The isometric may also have maximum temperature limitation based on mechanical properties of the excess for the allowable operation temperature depending on upon its corrosion resistance. This should be checked for a corrosion table. Diaphragm valve stem assembly. The diaphragm valve has stems that do not rotate. The valve is available for the indicating with a non-indicating stem, with the indicating stem with an identical with a non-indicating stem valve, except the longer stem is provided to extend up through the hand wheel for a non-indicating stem. The design of the hand rotate for the stem bushing, but it engages the stem threads to move stem up and down. With the stem moves so close, so with the pressure that is pinned in to the stem, the diaphragm in turn with the screw of the suppressor. Her diaphragm valve bonnet assembly. Some of the diaphragm valve with a quick opening bonnet with a lever operated with the bonnet. If it's interchangeable with the standard bonnet with a conventional weir type body with a 90-degree turn lever move the diaphragm with a full open, full close. Diaphragm valves may be also equipped with a chain wheel operated with the extended stem of the bevel, gear operators, air operators, hydraulic operators. Alright, many diaphragm valves used with a vacuum server. The standard bonnet construction can be employed with a vacuum server through the 4-inch in size. On valves in 4 inches and larger, a sealed evacuated bonnet should be employed. This is recommended to guard against premature diaphragm failure. Sealed bonnets are supplied with a seal bushing, non-indicating type of the seal bushing plus O-ring indicating type. The construction of the bonnet is similar to the diaphragm valve as illustrated in Figure 15. The design is recommended for the valve for handling dangerous liquid and gas event with a diaphragm failure. The materials will not be released to the atmosphere. If the material is being handled extremely hazardous, it is recommended that means of the provided to permit the safe disposal of the corroded from the bonnet. A reducing valve. The reducing valve is automatically reduce the supply pressure for the pre-selected pressure as long as the supply pressure is the least highest pressure of the selected pressure. Illustrated Figure 16 principal part of the reducing valve or main valve upward seating valve that has a piston on top of the valve stem, upward seating auxiliary on control valve with the controlling diaphragm and adjusting screw, spin and screw. Alright, it shows the adjusting screw, adjusting spring, controlling diaphragm, lock nut, piston steam port, auxiliary valve spring, and then high pressure port, low pressure port, main valve body drain connection, main valve spring. Or reducing valve operation controlled with a high pressure valve, with inlet with adjusting screw with the top of the valve, with the swim with the pressure into with the main valve, with the assist with the main valve, with the spring, with the keeping the reducing valve closed, with the pushing upward with the main valve disc. However, the swim with the high pressure bled into the auxiliary valve with the top of the main valve, with the auxiliary valve controlled with the emission with a high pressure with the piston with the top of the main valve, with the piston with a large surface of the air with the main valve disc, resulting in net downward force of the opening of the main valve, with the auxiliary valve with the controlled diaphragm located directly over the auxiliary valve. The controlled diaphragm transmit the downward force with the tens open over the auxiliary valve with the downward force exerted with the adjusting spring with the control with the adjusting screw, reducing the pressure from the main valve outlet with the bleed back of the chamber beneath the diaphragm to counteract with the downward force with the adjusting spring. Position of the auxiliary valve with the ultimately position of the main valve with the determined with the position of the diaphragm with the position of the diaphragm and determined with the strength of the opposing forces of the downward force adjusting spring versus the upward force of the outlet produced pressure. Other producing valves work on the same principle but are many uses gas, pneumatic, hydraulic controls in place with adjusting spring and screw. Non-variable the reducing valve illustrated in Figure 17 replaced with adjusting spring and screw with a non-pressurized done over the diaphragm of the valve stem with a connected either directly or indirectly diaphragm of the valve stem below with the diaphragm keep with the valve closed with the variable the valve value reduce the pressure bled off of the orifice beneath the diaphragm and open the valve with the valve position determine the strength of the opposing force of the downward force and pre-pressurized dome versus the upward force of the outlet reduce that pressure. So this shows your non-variable reducing valve, the dome loading chambers, separation plate, orifice, diaphragm plate, the dome separating plate, the plug for external charging, dome needle valve, the charge connection relief valve, pressurizing equalizer reservoir, diaphragm plate, spring outlet, cage, valve seat, body needle valve, actuating chamber, relief valve. Alright, non-variable reducing valves eliminate the need for the intermediate auxiliary valve with the round end of the variable reducing valve having opposing force or reacting directly on the diaphragm. Therefore, non-variable reducing valves are more responsive to large pressure variations or less susceptible to failure with the air than our variable reducing valves. Okay, pinch valve. The relatively inexpensive pinch valve that illustrated in Figure 18, simply with any of the valve designed simply a industrial version of the pinch cock. Use laboratory control of the flow of the fluids through a rubbering tubing. Pinch valves are suitable for on-off throttling shifts, however, they are effective if the throttle range is usually between 10 and 95% of the rated flow capacity. Pinch valves are ideally suited for handling storage liquid, large amounts of suspended solids, system conveying solids pneumatically because this operating mechanism is completely isolated from the fluid. These valves also found applicable with the corrosion. Metal contamination fluid might be a problem. Figure 18 shows the pinch valve, a stem, a pinching device, and then the valve body sleeve. The pinching control valve is a sleeve molded with a rubber or other synthetic material with a pinching mechanism. All operation portion of the control of the external to the valve. The molded valve sleeve is referred to as the valve body. Pinch valve bodies are manufactured natural synthetic rubber to plastic, which have the good abrasion resistant property. These properties permit little damage of the valve sleeve. Therefore, by providing virtually unimpeded flow, sleeves are available to either extended hubs or clamps designed to slip over the pipe and as the width of the flange and having standard dimensions. Your pinch valve bodies. The pinch valve has a molded body with a reinforced with the fabric. The pinch valve generally have the maximum operating temperature of 250 degrees. At 250 degrees, maximum operating pressure rises generally from 100 psi gauge for 1-inch diameter valve. The increase is a 15 psi gauge for a 12-inch diameter valve. Special pinch valves are available at temperature ranging from negative 100 degrees to 550 degrees Fahrenheit. Operation pressure is at 300 psi gauge. Most pinch valves are supplied with a sleeve valve body explode with another style fully with enclosed with a sleeve with a metallic body. The type of the control of the flow, either the conventional wheel slewing pinch device, hydraulically pneumatic with the pressure of the liquid, gas, and metal case, forcing the sleeve walls together to shut off the flow. Most exposed sleeve valves have limited vacuum application because of the tendency of the sleeve of the collapse of the vacuum is applied with the encased valves can be used in vacuum service applying the vacuum with a metal casing and thus preventing the collapse of the sleeve. Your butterfly valve. The butterfly valve is illustrated in figure 19 of the rotation motion valve that you the stop of the regulate with a certain fluid flow. Butterfly valves are quickly operated because of the 90-degree rotation handles move the disc with a fully closed with a fully open position. Larger butterfly valves are actuated with hand wheels connected with a stem through gears and provided with a mechanical advantage of the expense of the materials. Expense speed. Shows the typical butterfly valve operator seat and body and disc. Butterfly valves possess any of the advantage over the gate. Possess many advantages over the gate, globe, plug, ball valves, especially for the large valve applications. Saving the weight of space for the costs are most obvious advantages. Maintenance costs are usually low because there are minimal number of moving parts and therefore no pockets to trap fluids. Butterfly valves are especially well suited for the handling of large flows of the liquids and gases at relatively low pressure for the handling of the slurry liquids of large amounts of suspended solids. Your butterfly valves are built with the principal pipe at the diameter of the flow of the control element is a disc of the approximately the same diameter the inside of the diameter of the joining of the pipe, which rotates either vertical or horizontal disc. With the disc lies parallel to the piping running with the valve that is fully open with the disc approach with the perpendicular position. The valve is shut. Intermediate position for the throttling position can be secured in place by the handle locking device. Butterfly valve seat construction. Stoppage of the flow is accomplished with the valve disc seating against the seat. If it is on this inside of the diameter periphery over the valve body, many of the butterflies have an elastometric seat against for the disc seal. With on other butterfly valves, they have a sealing ring and arrangement. They use the clamp ring, back ring out of the serrated edged rubber ring with a design prevents extrusion. With the O-rings, an early design of metal disc was used to seat against the metal seat. The arrangement did not provide a leak-tight closure, but did provide sufficient closure to some applications, water distribution lines. Butterfly valve body construction. Butterfly valve body construction vary. The most economical wafer type of the fits between the two pipe flanges with another type of the log wafer design, which held in place between two pipe flanges, but by bolts that have joined the two flanges passes through the holes of the valve outer casing. Butterfly valves are available in conventional flange ends from bolting two pipe flanges in the threaded end construction. Butterfly valve disc and stem assembly. Stem of the disc and butterfly are a separate piece for the disc is bored with the receiver of the stem with the two mets of the secure of the disc with the stem and the stem of the disc rotates to the stem term with the first method of the disc is bored with the secured stem with the bolts and pins of the alternate method involved with the boring of the disc is before with the shaping of the upper stem bore with the fitted with the squared and hex shaped stem. This method allows the disc to float the seat at the center of the seat with a uniform sealing. The accomplished external stem fastener is eliminated. This assembly is advantage of the case of the covered disc and the corrosive application. In order for the disc to be held in the proper position, the stem must be extended to the end of the bottom of the disc and fitting of the bushing of the bottom of the valve body. One or two similar bushings along the upper portion of the stem as well. The bushing must be extended either resistant to the media being handled, sealed with a corrosive method. Media cannot be in contact with them. Stem seals are accomplished either by packing the conventional shut-in stuffing box or by means of O-ring seals. Some of the valve manufacturers, particularly with a specialized in handling corrosive materials, place a stem seal on the inside of the valve so that no material being handled by the valve can come in contact with the valve stem. And the stuffing box or external O-ring is employed, and fluid passing through the valve will come in contact with the valve stem. Alright, your needle valve. The needle valve shown in figure 20 is used with the most relatively fine adjustments for the amount of the fluid flow. The distinguished characteristic of the needle valve with the long tapered needle with the like point end of the valve stem with the needle acts of the disc, and then longer the part of the needle is smaller than the orifice of the valve seat, but it passes through the orifice before the needle seats. The arrangement permits very gradual increase with the decrease of the size of the opening of the needle valves are often used in component parts of the other more complicated valve. For example, the use of the sometimes reducing valves. It shows the hand wheel, the stem, the packaging, the bonnet, the body, and the needle valve and the stem point. The needle valve application. Most of the constant pressure governors with the handle needle valve to minimize the effect of the fluctuation pump discharge pressure. Needle valves are also used with some of the components of the automatic combustion control system, which are very precise flow regulations necessary. Alright, your needle valve body design. One type of the body design with the needle valve is the bar stock body. With the bar stock body, a bar is common in the globe type of the ball ball swiveling in the stem provide the necessary rotation for the seat, eating without damage to the bar stock body is illustrated in figure 21. Bar stock body instrument show the packaging, the bonnet threads, the ball disc, ball in the disc, and then the back seat. Needle valves are frequently used with the metering valve. The metering valves are used electrically or extremely fine flow control. The thin disc of the orifice allows with linear flow characters, therefore the number of hand wheel turns can directly correlate with the amount of flow. Typical metering valve has a stem with about 30-40 threads per inch. New valves generally use one style with a stem packing O-ring with a Teflon backing, rings, Teflon packaging cylinder. Needle valves are often equipped with replaceable seats for the ease of maintenance. Alright, your check valves. Your check valves are designed to prevent reversal flow of the piping system. The valves are activated with the flowing of the material in the pipe while the pressure of the fluid pass through the system opening of the valve, while any of the reversal flow with the valve closure is accomplished by weight of a check mechanism, back pressure by spring, and by a combination of these means. General type of the check valves are swing, tilting, disc, piston, butterfly, and stop. A swinging check valve. Swinging check valve is illustrated in figure 22 with the valve allows full unobstructed flow, automatically closes pressure, decreases. Valves are usually fully closed with the valve flows reaches the zero and prevents backflow. Turbulence pressure drops. The valves are very flow. Alright, shows the bonnet cover body, the flow inlet, the flow of this direction only. Has a hinge and a disc and a seat, and then it has a flow outlet. That's a swinging check valve. Your swinging check valve is normally recommended that you with a system employing gate valves because of the low pressure droplet cutoff of the valve. The swinging check valves are either the Y pattern or straight body design. Straight check valve is illustrated in figure 22. Either style of the disc and hinge is suspended with the body means with a hinge pin. Seating is either metal to metal, metal to seat. Composition discs are usually recommended in service where dirt or other particles may be present in the fluid where noticeable is objectionable and where positive shutoff is required. Or your straight body swinging check valves containing a disc that is hinged at the top of the disc seals again for the seat with an integral body. With the top of the check valve is usually a replaceable seat with its rings. The seating surface is displayed with a slight angle to permit easier opening of the low pressure, more positive sealing, less shock when closing under high pressure. Swinging check valves are usually insulated with a conjunction with the gate valves because they provide relatively free flow with the recommended lines of low velocity. Flow should not be used on lines pulsating flow with a continual flapping and pounding would be destructive to seating elements. This condition partially corrected by using a external lever and weight. Or your tilting disc check valve. The tilting disc check valve is illustrated in figure 23. Similar to swing check valves, like the swing check valve, the tilting disc type keeps the fluid resistant and turbulence low because of the straight through design. This shows the operation of tilting disc check valve. Shows your inlet flow, your seats, your hinge disc, and your supports. So this is the then the flow goes the outlet flow, seats and back, and so there's no backflow. Tilting check valves can be installed with a horizontal line, vertical lines having upward flow. Some of the designs simply fit between the two flames faces and provide a compact, lightweight installation, particularly large diameter valves. Alright, the disc lift off of the sheet, open the valve with the aerofoil design. The disc allows to float on the flow. This stops the built-in the biposition disc of the optimum flow characteristic. Large body cavity helps minimize the flow restriction. Flow decreases. The disc starts closing seals before reverse flows occurs. Back pressure against the disc moves it across the soft seat seal into the metal seal for tight shut-off without slamming. The reverse flow pressure is inefficient to cause the tight seal of the valve may be fitted with external lever and weight. These valves are available in soft seal ring, medium metal seal, seat seal, metal to metal seal. Later version is recommended with a higher temperature operation. Soft seal rings are replaceable, but valve must be removed with a line to make replacement. Alright, your lift check valve. The lift check valve illustrated in figure 24 commonly used with the piping system and globe valves being used with the flow control valve. They have similar seating arrangements as the globe valves. Lift check valves suitable to installation horizontal vertical lines, upward flow. They are recommended with the use of steam, air, gas, water on vapor lines with high flow velocities. These valves are available on 3 body patterns, horizontal, angle, and vertical. This shows your inlet, the body, plug, disc, and bonnet, and seat, and outlet. Lift check valve. Flow to the lift check valve must always be entered below of the sheet. The flow entered of the disc or ball raised with the guide of the sheet. The pressure upward flow. When the flow stops with the reverse, the disc or the ball is forced onto the seat with the valve body with the back flow with the gravity. Some types of lift check valves are installed horizontally. The design of the ball suspended by a system with guided ribs. The type of the check valve is designed generally employed in plastic check valves. The seat and metallic body lift check valves are either integral body or contain renewable seat rings. This construction is similar to the disc construction of globe valves, either metal composition disc, metal disc. Seat valves can be regrounded using the same techniques as used in 4 globe valves. Our figure 25 shows the piston check valve, which shows the valve stem, valve bonnet cage, spring space for seating surface, and your main plug valve. Alright, your piston check valve is illustrated in figure 25. Essentially, a lift check valve. It has a dash pot consisting of the piston and cylinder that provides a cushion effect during operation. Because similar to the design lift check valve, the flow of the characteristics through the piston check valve are essentially the same as through the lift check valve. Installation is the same as for a lift check valve. Flow must enter for the under the seat construction seat disc of the opposition. Check valve is the same for as the check valve. Piston check valves are used primarily with the junction of globe valve. The angle valves and piping system experiencing frequent changes in the flow direction. Valves of this type are used on water, steam, and air systems. Alright, this shows your butterfly check valves to this figure 26. Clamp plate, hinge clip, fasteners, flexible sealing member, valve plate, hinge position. Your butterfly check valves have a seating arrangement similar to the seating arrangement of the butterfly valve. The characteristics of these check valves are similar to the flow of the characteristics through butterfly valves. Constantly, the butterfly check valves are quiet frequently used in the system. Using butterfly valves in addition with the construction of the butterfly check valve is used in such ample space provided with the unobstructed movement of the butterfly valve disc within the check valve body without necessity of installing spacers. The butterfly check valve is designed based on a flexible sealing member against the bore of the valve body at an angle of 45 degrees, short distance, smooth from full open to full close, inhibits the slamming action found in some other type of check valve. Figure 26 illustrates an internal assembly of butterfly check valve. Because of the flow of the characteristics, some of the flow of the characteristics of butterfly valve, the application of these valves are much the same. Also, because of their relatively quiet operation, they found application of heating, ventilation, air conditioning system. Simplicity of the design also permits the construction of large diameters up to 72 inches. The use of the butterfly valve's basic body design lends to itself the insulation, seating ring, seating liners that construct many material with a permanent construction, corrosion-resistant valve. Less expensive that would be encountered and very necessary for the construction of the entire body with a higher alloy, more expensive metal. This is particularly true of construction such as the titanium flexible sealing members available Buna and neopropylene, Nordiol, hypolyene, Vitan, Tyon, urethane, butyl, silicone, Teflon as a standard with other materials available on special order. Valve body is essential for the length of the pipe with its fine threaded groove. The plain ends of the interior barrel to a fine finish. Flange ends can have liners of the various metal with the plastic installed depending on the surface requirements. Internal and fasteners are always of the same material as the liner. Alright, butterfly check valves may be installed with horizontally vertical with a vertical flow with the upward downward care should be taken to ensure that the valve is installed so that the entire flow comes from the hinge post ends of the valve and otherwise all flow will be stopped. Your stop check valve shows in figure 27 shows the actuator stem, bonnet, disc, and body, and flow inlet, flow outlet. Stop check valve illustrated in figure 27, the combination of lift check valve with a globe valve. This also stem with which close prevents disc from coming off the sheet, but it provides a tight seal with similar to the globe. When the stem is operated in opposition, the valve operates the lifted check with the stem does not connect with the disc functions to close the valve tightly to limit travel of the valve disc opening direction. Alright, your relief and safety valve. Relief and safety valve prevent equipment damage relative to an accidental overpressurization fluid system. They the difference between the relief valve and the safety valve the extent of the opening of the set point pressure. The relief valve is illustrated in figure 28. Generally gradually opens the inlet pressure increases above the set point, but the relief valve opens as necessary to relieve the overpressure condition. Safety valve illustrated in figure 29 rapidly drop pops fully open as soon as the pressure setting is reached. The safety valve will stay fully open until the pressure drops below steady pressure. Resetting the pressure lower than the actuating pressure set point. The difference between the actuating pressure set point and the pressure at which the safety valve resets is called the blowdown. Blowdown is expressed as a percentage of the actuating pressure set point. And it shows adjusting screws, springs, lock nuts, and the stem, and the disc, and the outlet, stem, and valve body, relief valve. Relief valves are typically used for the incompressible fluids such as water and oil. Safety valves are typically used for the compressible fluids and stems or other gases. Safety valves can often be used to distinguish by presence of external lever at the top of the valve body, which is used for the operational check. As indicated in figure 29, system pressure provides the force of attempting to push the disc. Safety valve off at sea with the same spring pressure on the stem is forcing the disc onto the seat. Pressure determines the spring compression. System pressure overcomes the spring pressure. The relief valve opens. System pressure is relieved. The valve closes when the spring pressure again overcomes the system pressure. Most relief safety valves open again for the force of the compression spring. The pressure set point is adjusting by turning adjusting nuts on the top of the yoke, increasing and decreasing spring compression. I show the adjusting nut, the hinge and lifting lever, spindle locking clip, adjusting ring screw, adjusting ring, disc insert, nozzle ring disc cotter pin guide, shows the path and arrows. And that's a safety valve. Alright, pilot operated relief valve. Pilot operated relief valve is designed to maintain pressure through a small passage to the top of the piston that is connected with the stem with the system pressure closes the main relief valve with a small pilot valve open the pressure to leave from the piston system pressure under the disc open the main relief valve. Those pilot valves are typically solenoid operated with engineering signal originating from the pressure measuring systems. Alright, summary. The following important information for this chapter is summarized below. The type of the valves and summary. The gate valve generally use the system of low resistance. For the fully open valve that desired, there is no needle throttle to the flow. Low valves are used in system good throttling characteristics. Low steep leakage is desired. Relatively high head loss. Open valve is acceptable. Ball valves are all quick and quarter turn off on operation and have power throttling characteristics. Plug valves are used to direct flow between the several different ports through this use a single valve. Diaphragm valves are used. The pinch valves are used. The system is desired for the entire operating mechanism to be completely isolated from the liquid. Butter valves provide significant advantage over the other valves' design, weight, and space, and cost for large valve applications. Check valves automatically open and allow the one direction seat to prevent the flow of the reverse direction. A stop check valve is in combination with a lift check valve and a globe valve incorporates the characteristics of both. Safety relief valves are used to provide automatic overpressurization protection of the system. Alright, valve actuators. The system type of actuator necessary to allow the positioning of the valve of the actuator vary from the simple manual hand wheels relatively complex electrical hydraulic manipulators. Alright, describe the construction principle operation of the following type of the valve actuators. Manual electromotor, pneumatic, hydraulic, and solenoid. Alright, introduction. Valve actuators are selected based on the number of the factors, including the torque necessary to operate the valve and the need for the automatic actuation. Type of the actuators include manual hand wheel, manual level electrical motor, pneumatic solenoid, hydraulic piston, self-actuated. All actuators except for the manual hand wheel lever and or adaptable automatic actuation. Manual fixed and hammer actuators. Manual actuators are capable of placing value in any position, placing the valve in any position, but do not permit automatic operation. The most common type of the mechanical actuator is a hand wheel. This type includes hand wheels fixed to the stem, and hammer hand wheels, and hand wheels connected to the stem and through gears. Figure 30 shows a fixed hand wheel. Hand wheels fixed to the stem. Illustrated in Figure 30 with a hand wheel fixed to the stem provide with the only mechanical advantage of the wheel, but when the valves are exposed to high operating temperature, valve binds and makes operation difficult. Alright, your hammer hand wheel, illustrated in Figure 31. Hammer hand wheel moves freely through the portion of the turn, then hits against the lug on the secondary wheel, and secondary wheel is attached to the valve stem, which is arrangement with the valve can be pounded or shut off with a tight closure to pound opening if it's stuck shut. Figure 31 shows a hammer hand wheel, primary wheel, secondary wheel, lugs, and threaded stem. Alright, gears. An additional mechanical advantage necessary with a manual operated valve with the valve binding is fitted with the manual operated gear heads as illustrated in Figure 32. As a special wrench to the hand wheel attached with the pinion shaft permits one individual to operate the valve while two individuals might be needed without gear advantages. Because several turns of the pinion are necessary to produce one turn of the valve stem, and the operating time of the large valve is exceptionally long. The use of the portable air motors connected to the pinion shaft increases the valve operating time. Shows manual gear head, a valve, stem, gear assembly, hand wheel, and alright, electric motor actuated. Electric motors permit manual, semi-automatic, automatic operation of the valve. The motors are usually mostly often open-close function, although they are adaptable to the position of the valve that add to opening the illustrated Figure 33. Motor is usually reversible high-speed type connected through a gear train to produce motor speed, thereby increasing the torque of the stem. The direction of the motor rotation determines the disk of the direction of this motion. Electrical actuation can be semi-automatic, where the motor is started with a control system. Hand wheel can be engaged with a gear train, provided the manual operating of the valve line switches normally provided at the stop of the motor, automatically fully open, fully closed valve position. Limit switches are operated with either physical position of the valve or torsional torque of the motor. It shows the motor and a crank stem and the gear assembly, drive stem, clutch and worm, gear stem, drive stem, gear assembly, crank stem, hand wheel. Alright, pneumatic actuators are provided in illustrated Figure 34, provide with the automatic, semi-automatic valve operation actuator translate an air signal to valve stem motion, air pressure acting on the diaphragm piston connected to the stem. Pneumatic actuators are used in throttle valves for opening and closed position. Fast action required when air pressure closes the valve. The spring actuator action opens the valve with the actuator's directing where the air pressure opens the valve spring. The action closes the valve. And the actuator is termed reversing acting. Duplex actuators have air supply with both sides of the diaphragm. The differential pressure causes the diaphragm positions the valve stem. Automatic operation provided with the air signal, air automatic controlled circuitry. Semi-automatic operations provided with the manual switches in the circuitry of the air control valves. This is your pneumatic air actuator starting at the bottom. You have your high pressure stem, your disc, and your reduced pressure stem, your seats, the valve body, the actuator valve body, the air actuator valve body, the air bladder, your operating air pressure from control pilot. Alright, hydraulic actuators. Hydraulic actuators provide semi-automatic, automatic positioning of the valve similar to pneumatic actuators. The actuators use pistons to convert signal pressure into a valve stem motion. Hydraulic fluid is fed into either side of the piston while the other side is drained or bled. Water or oil is used as the hydraulic fluid. Solenoid valves are typically used for automatic control of the hydraulic fluid to direct either opening or closing of the valve. Manual valves can also be used to controlling hydraulic fluid, thus providing semi-automatic operation. Your self-actuated valve using the system fluid, position valve, relief valve, safety valve, check valve, stem traps, and or example of self-actuated valves. All these valves are the same. There is the same system fluid actuating the valve. No source of the power outside the system fluid energy is necessary for the operation of these valves. And it shows a solenoid actuated valve to the Figure 35. We'll go over it real quick. It shows a plunger spring, seats, a plunger spring, a valve seat, a valve stem, your valve body, plunger, a coil, and conducting opening. Alright, solenoid actuated valves. Solenoid actuated valves provide automatic opening and closing valve position as illustrated in figure 35. Solenoid actuated valve is manually overridden with a permanent manual positioning of the valve as long as the override is manually positioned. Solenoid position of the valve extracting a magnetic slug attached to a valve stem. In single solenoid valve, spring pressure acts against the motion of the slug when the power is applied to the solenoid. These valves can be arranged such a power to the solenoid either opens or closes the valve. When the power of the solenoid is removed, the spring returns to the valve to the opposite position. Two solenoids can be used to provide both opening and closing and applying power to the appropriate solenoids. Alright, single solenoid valves return failed, open, failed, closing depending on the position of the valve. With the solenoid de-energized, falling, opening solenoid, fail, open, solenoid, fail, open. The single solenoid valves are termed as either as failed open or failed closed depending on the position of the valve with the solenoid de-energized. Fail open solenoid valves are open with a spring pressure closed by energizing the solenoid. Fail closed solenoid valves are closed by spring pressure and opened by energized the solenoid. Double solenoid valves are typically fail as is. That is, the valve position does not change when the both solenoids are de-energized. Open application solenoid valves are air systems such as those that supply air to pneumatic valve actuators. The solenoid valves are used to control the air supply pneumatic actuator, thus the position of the pneumatic actuated valve. Alright, speed power actuators. Plant safety consideration deactivate valve speed with a certain safety related valve. When the system must be very quickly slid to open a very fast valve actuation is required. With the opening of very fast valve resulting in injection relatively cold weather and hot system, slower opening necessary to minimize the thermal shock. Engineering, designing, selecting the actuator safety related valves based upon speed power requirements, availability of the energy to the actuator. In general fast actuation provided with a hydraulic pneumatic solenoid actuator. However, the solenoids are not practical large valve to cover the size of the power requirement would be excess. Also, hydraulic pneumatic actuators require a system for providing hydraulic pneumatic energy. The speed of the actuation in either case can be set by insulation appropriate size, or if it's hydraulic pneumatic lines, certain size cases of the valve that close the spring pressure, which is opposed with the hydraulic pneumatic pressure to keep valve open. Electric motors provide relatively fast actuating. Actual valve speed is set by a combination of motor speed and gear ratio. The combination can be selected to provide a full value of valve travel with a range from about 2 seconds to several seconds. Alright, valve position indication. Operators require indication of the position of certain valve to permit knowledgeable operation of the plant. For such valve, the remote valve position indicator will provide with the form of the position of light. This indicates the valves are open or closed. The remote valve operation indication circuits use position detectors that sense the stem and the disc position of the actuator position. One type of the position detector with the mechanical limit switch was physically operated by valve movement. Another type of magnetic switch that transform and sense move of the magnetic cords, which are physically operated by valve movement. Local valve position indicates refers to similar discernible characteristics of the valve. Indicates valve position. Ring stem valve position is indicated by stem position. Non-rising stem valves sometimes have small mechanical pointers that are operated with the valve actuator simultaneously with valve operation. Power actuated device typically have a mechanical pointer, provides local valve position indication. On the other hand, some valves do not have any features of position indication. Alright, summary. The most important part of the chapter is summarized as the valve actuator summary. Manual actuators, the most common type of the valve actuator. Manual actuators include hand wheels attached with the valve stem directly, hand wheels attached through gears to provide mechanical advantage. Electromotor actuators consist of reversible electrical motors connected through valve stem through gear train through reduced rotational speed and increased torque. Pneumatic actuators are air pressure on either or both sides of the diaphragm to provide force of the position of the valve. Hydraulic actuators are pressurized liquid, one on both sides of the piston, to provide force required for the position of the valve. Solenoid actuators have the magnetic slug attached to the valve stem. The force of the position valve comes with a magnetic attraction between the slug on the valve stem and the coil of the electromagnetic valve actuator. And that completes the reading of Department of Energy Fundamentals Handbook, Mechanical Science, Module 4, valves, and this is for the PDH course on valves.